Okay, so good day, everyone. Depending on what part of the world that you're in, it's afternoon where I am, and so I want to believe that if you're in India, it's evening. If you're in the US, it's morning, and the UK, it's about the same time with us here. So there's a convergence right now between our timing and the British Standard Timing. Okay, so if you guys don't mind, I want to welcome every one of you, and yeah, good evening, Amir. All right, so yeah, I think we can start. Every other person will join us midway. So yeah, so but before we start, let's talk a bit about programming. I know there are some Python gurus in the house here. Amir is one of them. Amir, we're going to have this session one time and you're going to be teaching it. I've not quite met Matt, but I know Anu is another Python guru in the house. So kindly confirm to me you can hear me, please, and that I'm not talking to myself.
Can hear you.
Okay, great. Okay, lovely. Okay, so today we're just going to be talking about object-oriented programming in Python, and it's going to be like a 3 to 4 part series, depending on how fast we move. So I'm going to be taking this introductory part, and if we don't finish this introductory part today, I'm going to continue next week, and then Thumb is going to be taking the remaining part of the classes. So I just asked, based on what we have done, to just set the foundation and set the ball rolling while he wraps up. You know, Thumb can be very amazing. So there are a lot of things he has already shown me that he wants to, you know, and I'm already excited because by the time you're out of this boot camp over the next 3 to 4 weeks, you'll be doing amazing things, you know, with your Python. So I'm just going to start, and yeah, every other person will join us shortly. Now, when you hear object-oriented programming, what comes to your mind? Anybody, feel free to unmute yourself and just, you know, just talk. What comes to your mind? Anybody? Anybody? Just feel free, unmute. Okay, no one is saying anything. Should I call names? Okay, so I'm just going to say Amir. Amir, talk to us. Let's tell us something about object-oriented programming. What do you think it is? And tell us about it.
All right. I hope you can hear me.
Yes, loud and clear.
So far, like, I'm not very familiar with what object-oriented programming is. My background is different. Yet, what I infer from all the Indian posts is that there is something that has to be more of a structured programming, as in, if I write a code in Python, someone else should be able to understand more of a organized and structural part or something of that sort.
Lovely, amazing. Anu, do you want to?
Like there is an aspect of reproducibility of the code.
Right, yeah. Right, lovely. Thank you. So Anu, do you want to add something? You want to say something about object-oriented programming?
No, please go on.
Okay, Matt, anything to say?
No, I don't have anything to add. This is totally new to me, so.
Oh, great. Okay. So now, but I want to believe you guys are also exposed to Python in the sense that you have seen Python being programmed before, or you even tried to write one or two things in Python. because we're going to do this same thing here right now. So I want to know, maybe I should just put a little bit of an introduction, like to Python, and then we talk about object-oriented programming. Okay. All right. So so this is what I'm going to do. The moment I start writing the Python code, once you don't understand or you are a bit lost, just let me know. I'm going to find you, and then we'll take it up from there. So what is object-oriented programming? Now, I like to look at object-oriented programming through a story. So I'm just going to tell you a story. And this is the story. So technology began to advance over the years. You know, we had a lot of dinosaurs, people who programmed with IBM, what's the name now? The mainframe, in those wee years of programming. But what we've discovered is that as technology began to advance, a certain kind of complexity was required, because you see, we were entering a generation called the generation of big data. So there were a lot of things that needed to change with the way data was being processed, with the way programs, people interacted with programs and all that. Usually, program began with a paradigm called procedural programming, and that was what programming began with. And what is procedural programming? You write a set of procedures. We're going to look at all of those shortly. You write a set of procedures step by step, and then you convert it into a full-blown program and stuff like that. And then from there, something called functional programming began. Again, like I said, we're going to define it and take examples shortly. And then we began to talk about object-oriented programming, all because there was a change in the level of complexity that was required in this program. So let's look at this in a story form. Now, let's say your friend Rick comes around visiting and he's hungry, and he wants to eat noodles. And I added a side note to say that, hey, in my side of the world here, noodles is like the easiest food to prepare. Sorry, excuse me. So, I'm sorry. So that's basically how it works. Noodles is like the fastest thing you can get, especially when a friend just happens on you and you need to make some food for the person. So you could just walk to the next neighborhood store, get some raw noodles, and then just prepare for the person. So this is usually what the procedure you take would look like. So you probably will first step out of your house and go to a neighborhood shop, buy the noodles, boil some water, put the noodles on fire and add some spices and allow it to simmer. And then when it's done, you serve the noodles, all right? And this looks like, these are all the procedures you're going to take. And, that's basically what programming is. Programming is a set of procedures, right, arranged logically to solve a particular problem, okay? So in this case, Rick has come and Rick wants you to feed him, and Rick wants to eat, and yeah, so this is what you do, basically, all right? And why you do this is because it's just Rick, okay? It's just Rick. I mean, you could always do that for your friend. But now, assume that Rick comes to your house another day and then announces, hey, Marty, I'm getting married and I want you to handle the cooking because I loved the way you make those noodles the other time. And we're expecting 5,000 guests. And they have indicated they want to eat noodles. Now, I can assure you that you are not going to treat it the same way you did when it was just Rick. Why? Because when it was just Rick, it was just Rick. You just went to the neighborhood store, bought just maybe a pack or two of noodles and stuff like that. But in this case, you're looking at 5,000 people. So how do you deal with this? You would notice that something has happened because the endpoint of the tasks look the same. I mean, it's to prepare noodles. I mean, whether you're preparing the noodles for Rick alone or for his guests, the task is the same, prepare noodles. But the level of complexity is different, all right? And what this does is that it makes you have to now approach this task of preparing for Rick's wedding in a different way. While you're preparing noodles for Ricky alone, a simple procedure could just suffice. Buy this, boil this, make it simmer. But to prepare for Ricky's wedding, you can't just have a simple set of procedures. You have to treat that wedding as a project. So you would notice that you have a lot of things that you have to put in place for that Rick's wedding to be a success. You see, and what does this mean? It means that first you have to identify all the various actors that you would need to help you with the project. So you will need to identify, okay, there's somebody definitely going to be a procurement manager, because buying noodles for 5,000 people is not child's play. So if you were just Rick alone, you could just buy from the neighborhood store. But hey, the neighborhood store cannot stock for 5,000 people. So you probably have to go to a proper market, maybe a Walmart or some other place to get the supplies. All right. So you will need a procurement manager, because sometimes you might get to Walmart and say, hey, we don't have up to 5,000 packs of noodles. So we have to source from different places and all that. And you don't want that to bug you. So you want to have a procurement manager. All right. Buy all the noodles and all the spices. Then you also want to have a kitchen manager. All right. And the kitchen manager will ensure that all the spices are cut, that the gas cookers, the cylinders, everything is on point, the spices are added, and everything is just happening the way they should happen. All right. They get to taste the food to ensure that, okay, the spicing is adequate. We're going to monitor the noodles till it cooks. All right. So that's the role of the kitchen manager. Then you probably will also need a project manager who would supervise every part of the project to make sure that, hey, this project of noodle cooking comes out tops. Very, 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 very interesting and amazing. All right. So these are just a few set of people you're going to need. All right. This is not by any means an exhaustive list. It's just a few set of people that you're going to say, okay, off the top of my head, I'm going to need these people. What I want you to look and not lose sight of is to always remember the task was the same: prepare noodles. All right. But the level of complexity was what made it look different. So, and it's the same thing in this current age that we're in. Initially, programming was just a set of procedures. Hey, buy this, go to the neighbor store, and all that. But right now, there's a level of complexity that is expected of your program to be able to serve people. So because of that, the procedural pattern of programming could not suffice anymore. So right now we have to think about object-oriented programming. And what you have seen now is that we have identified the actors, and that's really the first step in object-oriented programming. You want to identify who are the actors that I need to make this thing work, because whenever you have something that is very complex, it becomes like a project. All right. So you identify actors, and when I say actors, I'm going to show you how it plays out. All right. So you identify who are the actors in this thing, in this stuff that I'm doing right now, that are going to make this project a success. So you've identified the procurement manager, you've identified the kitchen manager, you've identified the project manager. And in programming lingo, each of these things, the procurement manager, the kitchen manager, and the project manager, are called classes. A class is a grouping, all right, used to, how do I put it now? It's like a grouping used to class various tasks or actors together in your program, the program that you're writing, okay? So now, usually, before you hire anybody to fill all of these roles that you see here, procurement manager role, kitchen manager, procurement, project manager role, you have to do something that is called a job analysis, all right? And a job analysis is going to reveal two things. It's going to reveal the person specification, and it's also going to reveal the job description. So this is how it works. Now, I'm sure you probably might have applied for a job recently. You'll notice that the vacancy advertised will read something like this: the software engineer wanted from maybe India or New Delhi, and they will tell you what the person should look like. So the person should have a BSc or an MSc in statistics or computer science. The person should have 3 years of experience or 5 years of experience. The person should have this. Now, that is called the person specification. So that is just a list of the attributes that this person should have. And then the second thing in that job analysis is called the job description, all right? And the job description basically is the function the person is expected to perform. So these two things are what determines who comes in to take those jobs that we just saw earlier, all right? So in this case, let's now translate this to Python programming. Remember, we have identified the person specification, all right? We have identified the job descriptions, okay? So now, if we want to make this a program, and one of the things I want to make clear is that when we talk about actors, sometimes it's not even just people like project manager, whatever. It might even actually be something, a thing, not even like a person. Okay, I'm going to show that when we start looking at examples. So let's do a job analysis for each of the tasks in the job that we identified. Our aim is to get the person specification and the job description. So we pick the first task. Again, remember, don't lose sight of the fact that what we are trying to do is to prepare noodles for Rick's wedding. All right. So we pick the first we pick the first person, that's the procurement manager, that's the first class. All right. Remember, I told you these things are classes, and I'm going to explain how these things tie up together when I eventually round up this example. So the first class is the procurement manager. The specification that we expect, okay, we expect, yeah, every procurement manager should have a name. In fact, I would not employ anybody that doesn't have a name, because I mean, how do I refer to you? All right. And then, okay, you need to have years of experience. But okay, so that's all we need from procurement manager. The kitchen manager will also have a name and should have some years of experience. All right. But the project manager, we think, should have a name, should have a degree, should have years of experience. Now, these are the things that we expect from the people. These are the person specifications. Now, on the other hand, we have their job descriptions. So for the procurement manager, we expect you to buy ingredients, we expect you to receive the ingredients into the store, we expect you to ensure that the storage is safe and stuff like that. For the kitchen manager, we expect you to prepare the ingredients, we expect that you should monitor the cooking, and you should serve food in the dishes and all that for the guests. And then for the project manager, we expect that you should create the project plan, you should coordinate the team, and should liaise with the project sponsor. All right. In object-oriented programming lingo, these person specification that you have are called class properties. And then these job descriptions are called class methods. So if you're used to Python, or maybe you've even tried to do one or two things in Python, you would have heard us say this object, this property, this method. Is very simple. An object is an instance of a class, all right? The properties are the things that we expect them to have. And then the methods are, these things we expect them to do. A method is actually a function, but the difference between a function and a method is that when a function is fixed into a class as part of that class attributes, it becomes a method. That's why we call it a method. But a method is just basically a function. Okay. So now we are going to go to Python to create this project manager. So we're just going to go to Python and we're going to create this project manager. Remember, we're just using noodles as an example. Okay. I don't know if anybody is going to write an app that is going to help cook noodles in the recent future, but I just thought to use this because it's going to explain what we want to do. All right. So remember, the first thing we talked about was that we will have to initialize the various classes required to execute and do projects. Remember that when we're looking at this, let me just keep this handy so that we do not lose sight of it. Okay, so I'll just keep that handy on inside so that I can switch both screens. So the first person that we wanted to have was our procurement manager. The second was the kitchen manager. The third was the project manager. and the project manager being the boss, all right, is like the most important of all of them. So the first thing we're going to do if we're doing object-oriented programming is to define the class, all right? So like I said, you have to define both the properties and the methods as part of the class. Now, this is how it looks. So if you want to define a class in Python, you start with the word class, all right? And then project manager. So this is the first person with the project manager, and we're trying to define his class. Now, the first part of this whole thing, all right, this whole part here is to initialize the properties or attributes, if you like. And then every other thing that comes after is to initialize the methods. Okay, so now to initialize the property, you start with def in Python. Def is a keyword used in classes, all right? And def simply means to define. So you're trying to just define the boundaries of this program. So init means to initialize because you're trying to create the first instance, and that's what we have here, because when we create all of this, we are initializing. Initializing means to like start up, you know, the whole thing as a project. So you would notice that in Python we start with this thing self. I can always change this to anything. I can change it to Amir, I can change it to Anu or to Matt or whatever, all right? But I just put self here because that's the standard most people use. So they put self here. Self is to just say, okay, we are now starting an instance of a class, all right? We're initializing a class. So the first, if you look at these attributes that we talked about here, the first thing that we expect the project manager to have is a name. So you would see that here, I have put the name as one of the first properties this guy should have. He should also have a degree, and then he should also have years of experience, all right? So in Python, you now have to assign these tasks to variables. Again, we're going to look at how all of this work much later when we start executing real classes in Python code. So self.name, which is this, will be assigned to a variable called name. Self.degree, which is this, will be assigned to a variable called degree. And then self.years of experience, which is this property here, will be assigned to a variable called years of experience, all right? And since these are all the properties that we need from this guy, we're done with this. Now, the next thing we're going to initialize are the jobs that we expect from this guy. So for the project manager, we expect him to be able to create project plan, we expect him to coordinate the team, we expect him to liaise with project sponsor and do everything, all right? So we'll come here and then initialize that one. So we'll have the first one, create project plan, all right? And this is a function again. So we're defining a function, and this self again means we're just telling Python that this function is tied to this class, all right? So then we would tell the output we expect from a project manager by way of project manager document. So whenever you expect a document, most times you want to use the print keyword. So you're going to say, okay, print, this is my project plan. Again, like I said, this is just an example. It's just a joke, all right? It's not a real, it's not something real. Now, the next thing is def, coordinate team. This project manager too is expected, it's one of his functions, is expected to coordinate the team. So one of the outputs is that most times project managers shout, hey, everybody fall in line, listen, you know, stuff like that. So yeah, so that's one of the functions that is expected, all right? So the next class that we have are the procurement manager, name and years of experience. And okay, Amir, I'm going to talk more about the self attributes shortly. So the next attributes we have are the procurement manager and the kitchen manager. Those are the next classes that we have. So if you look at this class, you will see procurement manager is the same process again, self. We'll say what we want, the attributes that we want this procurement manager to have. All right. And then we will talk about self.name. Or you know what? I'm thinking maybe I should jump this for now and go to the end, all right, of this. Okay, let me just jump all of this heavy Python code for now. I'll come back to it. Maybe when we take an example of these programming paradigms, it will make things a bit more relatable. So remember, like I told you that earlier, you can have a list of processes, you can have a list of procedures and all that, you know, when you want to do anything at all. Programming is just telling the computer step by step what procedures to follow. So in this case now, I'm just giving another example. We want to create a simple order system that allows a customer to add products to their card, or sorry, this should be cart rather, and check out by making payments with their credit card alone, all right? So this should be cart. Now, usually what happens, the process flow is that the customer first opens the order cart, customer searches for products to add to the cart, customer fills his cart and indicates to checkout, customer provides his credit card and validates the transaction. And by validating the transaction will mean the customer clicks OK and then pays. And this is basically what you do when you shop on Alibaba, on any of all of these popular e-commerce sites. All right. So for like I told you when we were starting, for every procedure, every use case, everything you want to create a program for, one of the things that happens is that they all exist in procedures. All right. And you can actually do procedural programming to solve this same problem, in which case you will need to write sub-procedures. One language that works very well with procedural programming is BASIC. They call it BASIC. So you have Visual Basic, Quick Basic, and a couple of other basic family members. So this is what you'll see most times when you open BASIC. The first procedure would probably be for creation of carts. So you have procedure 1 for creation of carts, and then usually starts with a sub and an end sub to show when the procedure starts and when it ends. So after that, you proceed to the next procedure, which is the procedure of adding products, because the customer has to search for products and add it to his cart. So you have that as a second procedure. Then you write the third procedure, which is for the customer to fill his cart and stuff like that and provide his credit card. So you just keep writing procedure upon procedure upon procedure. Now, this is procedural programming. It doesn't work again, or well, it doesn't really work again anymore, because a lot of all the requirements that we have from users these days are very complex. So same use case, customer opens cart and all that. But if you are going to use functional programming, what will happen is that you're going to have to identify all of this and create them as functions. So for each of this, the solution would be 1, customer opens order cart. So what will happen is that you're going to create functions. All right, so the first function will now be, let's call it function open carts. All right, and then when you're done with that, you write the function and you end the function, end function. That's if you're writing in BASIC or any of all this language. But in Python, you start with a def. So you def the function, which is open cart. And then by the time you're done, you say what you want the function to do, whether to return a particular value or a calculation, or to just print something out. Okay, so that's it. So whenever you want to use functional programming to solve a particular programming problem, you will just continue writing functions upon functions upon functions. So you're going to write the first function for open cart. Then when you're done with that, you write another function for search products. Then you write what you want this function to do, but I'll just put pass here. Then you have another function for validate credit card. So let's validate card. All right. And then let me pass again. So when you're done writing all those functions, by the time you're passing this into the program you want to build, at every point where you need this thing done, you just call the function. So at the point that the customer needs to open his cart, the moment the customer clicks on that open cart or whatever it is that he sees on the screen, what happens is that the open cart function is called. So that cart function comes and, you know, he does what he wants, then it returns the value, or it does whatever it is that you want it to do. All right. And then when that has been that function has been executed, by the time the customer gets to the next phase now, which is to search for product, another function is called again from the app. The function now does everything that the customer needs to help search for the product. And then when the customer is done searching for the product and he's populated his cart, the customer now clicks on pay with maybe Visa or MasterCard or even PayPal or whatever. The moment the customer clicks on that again, another function is called, all right? And it comes straight to, you know, help do whatever it is that you have asked it to do to validate that card. So that's how functional programming works. Remember, it's different from procedural programming where we just keep writing sub procedures. So the first is open cart. We'll write all the procedures that it's going to take, do this, do that. When the customer sees this, the customer will do that. We'll declare the variables. We'll do all of that. That's procedural programming. Now, this same problem, if we want to solve it using an object-oriented paradigm, the first thing we need to do is to identify the actors that are in this scenario. So you can see the actors are number one, customer, because the customer has to open a cart. And then the other one is the cart, because the cart has to warehouse everything that the customer wants, you know, to buy. And then another actor here we can see are the products, because the customer has to buy products. You can see another actor here. We'll see credit card. We'll see all of that. So you first have to identify all the actors. All right. Then by the time you have identified all the actors, you'll now start looking at all the things that is required of the actors. So for example, for the customer, we expect that the customer has a name, because yeah, he should have a name that he will put into the order form. Then we expect he has an ID number, that's the customer number or something. We also expect that he should have a credit card number, because he has a credit card, you know, that he wants to pay with. Okay. And what are the functions the customer does when he's on this app? When the customer is on this app, one of the first things he should do is to select product. So we're going to write a function. Remember, I told you that methods are functions. Methods are basically functions that exist inside a class. So what you're seeing here is a customer class, you're seeing a product class, you're seeing a cart class, all right? So for the customer, the customer's method is to select a product, all right? So that's what the customer will do here, all right? And for the product, what are the product's attributes? Again, we expect the product should have a name, we expect an ID number, we expect that also the products, we do not expect a method, because really the product is being acted upon, all right? So, but sometimes you can have a method. And then for the cart, we expect that the cart should have an ID number. We expect that the cart should not have a method too, because, you know, it's been acted upon. But again, sometimes depending on the project design, you can actually have some things that the cart is doing, depending on who is designing the product. So, but basically, this is just something simplistic to just show you how the three paradigms relate. So the first one, we don't think about objects. We just create variables and create steps, procedures. The second one is functions. We don't think about procedures and other. We just think about functions. So we think in terms of functionality. What do we expect? What functions do we expect to happen for these things that the customer wants to do to be executed? So we just come up with those functions and write them. And then at every point in time, there's a function call, you know, that brings that information to the front of the app. So that's how it happens in OOP. So in this case, like we were looking at earlier, what we were looking at was that if we were trying to build an app that was going to prepare, for the wedding, this is how the app was going to look like. All right, so we have created the properties, and properties are also attributes, all right? And then we've also seen the methods, okay? So this is how it looks like in Python. You would have the procurement manager, you would have the kitchen manager. So this is called initialization, because in initialization, what we do is we set the dimensions, all right? Now, after we have set the dimensions, the next thing we'll now do is to instantiate all the classes. What is instantiation? For example, in this example that we have here now, we have said we need a project manager, we have said we need a kitchen manager, we have said we need a procurement manager. Now we need to hire people to fill this role. So we have to hire James to be the project manager. We have to hire Martha to be a procurement manager. We hire Sue and Robert to be kitchen managers. So the process of hiring James, Martha, Sue, and Robert in object-oriented programming is called instantiation, because we're creating instances of the class. So now we have a project manager who is named James. That's an instance. And if James messes up, we could fire him tomorrow and bring another person. So we will now have another project manager who is named John. All right. So an instance of a class is what we call an object. And that is what the whole object-oriented programming you've heard about is all about. So we're trying to say, okay, how can we create classes that like blueprints, all right? And then create objects, instances like people like James, like Martha, all right? Objects that would, have these class attributes and these class methods to be able to execute what we want them to execute. So this is what it looks like in Python code. If you want to instantiate the first object, which is project manager, and his name is James, and he has a BSc, and he has 10 years of experience. Remember, when we were creating this project manager class here, we said the project manager is going to have a name, he's going to have a degree, and he's going to have years of experience. So the moment we try to instantiate, let me just add that here. So let me just add that code here. Once we try to instantiate project manager, and maybe let's just call this PM, okay? And we tell Python that PM is an instance of, sorry, let me just say Python. So PM is an instance of the project manager class. All right. The moment we put a bracket here, okay, let me just run this. That's the problem with Google Colab. Once you leave it for a while, it just you need to refresh your code again. So let me recreate it here. So PM is a project manager class. So you can see I have the option here now, project manager class. And the moment I put that bracket, you'll see Python will give me all the things that are expected from a project manager to initialize it. So you'll see that Python is telling me, hey, to initialize this project manager, that's to define it and initialize it. We need a name, we need a degree, and we need years of experience. So I'm just going to tell Python, hey, okay, so our project manager's name is James. All right. The next thing is a degree. He has a bachelor's. So maybe I should just put a bachelor's here. Bachelor's, comma. And then the last thing is expected from his years of experience in numbers. So I could just put 10 years of experience. So by doing this now, I can now inherit the functions and the methods. Because remember, the moment we tell Python that this guy is a project manager, Python automatically expects that he has a name, he has a degree, and he has years of experience, and that he can create a project report, he can manage a team, he can. So when I come here, I can just tell Python, I want you to print out. Okay, someone has a question? Anyone? None? Okay, great. So let me just go on. Please, if you have a question, just you can unmute and ask, or you can put it in the chat and I will look at it. So in this case now, I want to tell Python that I want you to print the PM's name for me. I know you must have noticed in Python, we use dots a lot. So you could have seen numpy dots, this, pandas dots, this, whatever dots, whatever. It's simple. We're just trying to say, okay, pandas is the class. And when we put a dot, we are trying to reach out into either an attribute in pandas or a method or a function, like method and function, they're basically the same thing. So when we say something like, let me just open a new collab, or okay, let me just open a new, okay, let me just finish it. So when I say PM dot name, I'm telling Python, this guy called PM, this project manager here, this first one we're instantiating, I want you to reach into his class here, all right, and tell me about his name. So Python is going to reach into the definition that we gave here and say, okay, name is actually an attribute. So it means that anything that comes immediately after this self here is actually James' name. So when I print it out, it's going to give me James, because Python is already saying, okay, so whatever is here immediately after is the name. Same thing if I print pm.degree, all right? So when I run this, it's going to give me his degree, because like I said, I've already defined it, okay? I've defined all of the boundaries. And then same thing if I say pm.years of experience, all right? To tell me 10, because that's the number of years of experience that he has. So for this guy called PM now, for this PM that we have initialized, since he's a product manager, I expect that this guy should be able to coordinate a team. You can see the options are already coming out. He should be able to create a project plan. He should be able to, you know, so you would notice something whenever you're coding in Python. If you see a box, all right, like this, either in your Jupyter notebook, in your Visual Studio Code, or whatever ID like Colab that you're using, this box here indicates that what you're dealing with is a method. If you see a spanner like this, it indicates that it's an attribute or a property or a feature. So spanner for property, this for method. So when I say, hey, you're a project manager, you should be able to create a project plan. Once I call that create project plan function, the guy is just going to say, hey, this is my project plan. Then he starts spitting out his project plan, all right? So that's basically how these things work. But where is the game changer? The game changer is where the flow begins. That is step 3. Because in the instantiation and in the initialization, all we're just doing is setting boundaries. So now we want to commence this project, because I mean, yes, we have gotten the project managers, we've gotten the kitchen managers. So we want to do the real thing, which is the cooking for the wedding. So the first thing that we expect to do, which is the project flow, is that we expect that the project manager is going to give us his project plan. That's the first thing in the project. So if I'm writing that app, the first thing I'm going to write is pm.project plan, because I need to call that function to say, okay, hey, we are starting now, show us your project plan. So after the project manager has given us his project plan, which is what this function is meant to return, then we're like, okay, great. So the next thing is for the procurement manager to go to the market. Remember, when we were also defining procurement manager, we also defined that the procurement manager is expected as one of his functions to buy ingredients, all right? and go to the market. So we are going to call that function. That's the next thing that will happen. The the procurement manager has to go buy things. So we call that. So let me just run this so that you can see how it runs. Okay, so the project manager has given us his project plan, and then the procurement manager has bought ingredients. Okay, sorry, I need to run. Okay, I've not run this one. I need to run this and this and this. Okay, so now I'm just going to run this, and you'll see, okay, so the procurement manager is telling us now, I've gone to the farmer's market to buy food. So what's the third thing? The third process after that is that we have to receive the items that have been bought into store. That's the third thing in the process flow. Remember, we're following a series of steps that we have identified earlier in this flow here. All right. Like go to neighborhood and all that. So we're just following a series of steps for the objects that we have identified. So I'm just going to go back to this place now and say, okay, so since the procurement manager has gone to the store, the next thing we expect him to do is to receive items into store. And again, for that, we will call because if you look at the job descriptions here that we have done in our classes, you would see that the procurement manager is also the one that should receive the items into the store. So we are going to call that function again so that he can execute that thing in the app. So procurement manager dot, and then again, we'll see there receive items. So once we call that function and we enter it, you see project manager declares, I hereby receive the following items into store. And then after receiving items, the next thing that happens is that we want to get our kitchen managers to start cooking. So the first thing that happens is we get the kitchen managers to prepare the ingredients. All right. So let me just call this preparation of ingredients by kitchen managers. Okay, and to do this, again, whenever you need something done, it means you're trying to call a function from one of the actors that you have identified in your program. All right, so that's one of the things you want to call a function from one of the actors that is in the program. So to do that, we call the kitchen manager. But remember, we have two kitchen managers here. So we have kitchen manager 1, which is Sue, and we have kitchen manager 2, which is Robert, which we initialized here. All right. So it will now ask us which of the kitchen managers is going to do this. So I'm just going to say kitchen manager 1. So kitchen manager 1 is a person, and we need him to monitor the cooking. On the left, we need to prepare ingredients. All right. And then we get that to run. So this one has received the items to the store, and he's already now preparing it. And then for kitchen manager 2, we need the second kitchen manager to monitor the cooking. So again, all right, so this kitchen manager is watching the noodles till they simmer like that. So that's basically how object-oriented programming works. It's just a series of you calling functions or attributes or methods. Now, this is just a very simplistic case because, like I said, it's just to show how object-oriented programming works. In real life, you will deal with issues like control structures, because sometimes you want to ask, okay, what if the kitchen manager goes to the store to get more ingredients and there are no more ingredients? What should he do or what should she do? Then you have to write an if statement. And what if the store is locked? What should she do? Okay, she should keep knocking until someone opens. So you have to write a loop statement to say, as long as the door is locked or while the door is locked, keep knocking until someone opens, stuff like that. So like I said, this is just a very simplistic method of doing object-oriented programming. When you face a real project, you're going to now have to do real object-oriented programming that has things like loops, control structures, conditional statements, and all of that. So, yeah, I am going to stop here for questions. And I hope I have not confused anybody. Okay, so please, questions. Questions? Okay, thank you, Aziz. I see an applause. I will take that I tried, that I didn't confuse everyone.
Yes, you did a good job. You took so long trying to explaining that for us to get it. This is what I lack in the first place. You see, last time I asked a question that I'm confused about the OOP and things like that. But the approach you use to explain is very, very good. I appreciate you for that. Thank you very much.
Thank you, Aziz.
So one thing I just want to request is that I will want you to be sure to upload this picture, this video early, so that I can be able to go through it before next class.
No problems. I will do that today or latest by tomorrow morning.
Thank you very much.
All right. Thank you. Okay, Anu. Oh, Matt, thank you. I was really scared. I thought I had lost everyone. I thought I'd lost everyone, so I was really scared, and that was why I was looking forward to the question time so that I could clear any doubts that. Yeah, please go ahead.
Oh, no problem, no problem. Thank you.
Okay, so it's great, it's perfect.
Yeah.
Okay.
Very basic and explanatory.